Good day, my name is Joanne Correia, student number 629335590. I'll be presenting a project for the module code GEO3701, Geology for Engineers for the Department of Civil Engineering at the University of South Africa. The project brief stated that I have been appointed to undertake a desk study for a 400 or 132 kilovolt substation located north of the Bronkhorstspruit Road in Pretoria. The development will have the following infrastructures: a power transformer, high voltage switchgear, instrument transformer, surge arresters, post insulators, and steel structures and foundations. Site description. The site is located to the north of the N4 and to the east of Solomon Muhlangu Drive at GPS coordinates 25 degrees 45 minutes 12 seconds south and 28 degrees 24 minutes 49 seconds east. The site has an approximate elevation of 1,354 meters above sea level with an area of 500 by 500 meters or 25 hectares. Climatic area and topographic data. The average yearly rainfall for this region is approximately 675 millimeters. The average maximum temperature in the summer seasons is 24 degrees Celsius and the average minimum for the winter season is 12.8 degrees Celsius. According to the Vaynard area, the site has a moderate climate with an approximate Vaynard N value between 2 and 5. This value shows that the predominant pedicrete is ferrocrete. The topographical contours were obtained from the City of Tshwane GIS map systems. This showed that the highest elevation to the north of the site is 1,355 meters above sea level, while the lowest elevation the site falls on is 1,340 meters above sea level. The difference in elevation is approximately 15 meters. The nature of investigation for soils above the water table and saturated soils. The field tests required include boreholes or trial pits, in situ tests, cross-jacking tests, extract undisturbed samples, perform Lungien tests, measure the water table level, perform tensometer or suction probe tests. The laboratory tests required would be to use an odometer to perform density tests, undrained and drained triaxial tests, on unsaturated soil to perform blender element. For the property index, the Atterberg limits should be tested as well as the grading analysis and moisture content. For permeability, perform the falling and constant head test, test the swell under pressure for heave, test the degree of saturation, and use Frohland thermal conductivity to test the soil suction pressure. Occupational health and safety. The following regulations form part of the Occupational Health and Safety Act and should be used when preparing a geotechnical investigation. Noise-induced hearing loss regulation 2003, General Safety Regulation 1986, Electrical Machinery Regulation 1988, Driven Machinery Regulation 2015, General Machinery Regulation 1988, and the Construction Regulation 2014, which is most often used. Stormwater drainage concept. The figure shows how the concept design will use the natural slope of the contours to allow the stormwater to flow southwest to a localized point towards an attenuation dam. I have proposed that an attenuation dam be constructed to collect the runoff of the site. The water will be retained in the dam and released at such a rate that the rate of runoff post-development will equal the current pre-development rate. Identification of geology of the site. The stratigraphy was identified using the Council of Geosciences map. The stratigraphy of the site is as follows. In the table you can see the main elements of how the stratigraphy is formed. The main groups we'll focus on is the supergroup, which is the Transvaal supergroup or the Transvaal basin. The group is the Pretoria group and the formation of the rock is Silverton, which is also known as shale. Problem soils. The information obtained through the geotechnical investigation is used to assess the stability of the site for designing and constructing the proposed substation. With regard to the stability, serviceability, care of construction, and acceptable performance. Problem soils identified for building structures and service pipes are collapsible soils, expansive soils, soft clays, and paleogenic material. Engineering impacts of shale are expansive clay, low shear strength, high settlement, and slaking when exposed. Identification of material sources. The residual material can be used as lower selected layer material for the roads. The 150 mm topsoil removed for site clearance can be stockpiled and used for landscape purposes after construction. Due to the predominant material being clay, imported G6 or G7 material is needed for the roads. If blasting is required, the hard material obtained after blasting can be used as dump rock for the installation of the services. Imported crushed stone of 80 mm or smaller would be required for the compaction of the platforms. Recommendations. Due to the nature of the area having hard rock, the bill of quantities should include an item for excavation of hard materials and/or blasting. Water control of open trenches should be monitored to minimize saturation of the clay material. An attenuation dam should be constructed for the stormwater management. Pipes should be laid with thicker stone beds in areas where the water table poses a risk. I would like to thank you for watching my presentation for the Geology for Engineers project for semester 2 of 2022.